These are the first 5 problems on the front of the study guide for Algebra B, Test 5, Quarter 2. So the first 2 problems are going to ask us to graph systems of inequalities. And one of the tests will have a vertical line and the other will have a horizontal line. So there are examples of both on the back side of this practice test, or the study guide that I call it. Anyhow, this line right here is just a y is greater than 2. So when we have no x, we are talking about a horizontal line. So this is horizontal, and the way I remember it is if y is greater than 2, that means that y can only, the line itself is crossing the y-axis at 2. And so all the values of y have to be bigger than 2, so what we have to use is a line that represents that y at 2 is a border, but not actual solutions on that line. So that's why we use that dashed or dotted line. And so it's just a horizontal line that goes through y at 2. So the values of y are bigger than 2, so that means that I'm going to end up shading above, because those are the bigger y values. And so I move on to the next line, and the next line is in slope-intercept form. So we'll take that y-intercept right here, positive 4. We're going to go up 4 spaces and put a dot. And then we use the slope. Slope is negative 2 to 3. So that means you're going to go down 2 and then to the right 3 spaces. And you could do that a few times. Get some points on that line. We could also go the other way, up 2 to the left 3 as well. And that gives us lots of points, so we can draw a nice line through. Now we look at the inequality sign and see this line right here. This tells us that we end up having a solid line. And so what that means is all the points on the line are solutions. But we also have other points that are off the line. But which side of the line do we shade? Well, look at the inequality. It's a positive y is less than or equal to. Equal to meant the solid line. Less than means smaller y's. Smaller y's are below the line, because if you're at this point right here, the y value needs to be less than that. So that's why we're going to end up shading down. Now, we can also shade down on this side, but because we're dealing with a system, we have to go with where the 2 lines agree. And the only area in which the 2 lines agree to be above the black and below the blue is right in this region here. And so that's what you'll be doing for me. You'll be graphing lines. So some of you will have horizontal lines to graph, some will have vertical lines. The vertical lines would be ones with just x, and that's what we see in this next example. So let's take a look at it. So our first line has 3 plus 3y is less than or equal to x. You've got a choice here. It's not in slope-intercept form. You could put it in slope-intercept form, or you can use xy intercepts. And I'm going to try xy intercepts on this next one. So what I'm going to do is I'm going to take this 3y and I'm going to move it to the other side. So let me rewrite my equation here. I'll write that as 3 plus 3x is, or 3y, 3y is less than or equal to x. So what I'm going to do is I'm going to move that y term to the other side. And I think this is going to just give me the answer a little bit faster. That's the only reason I'm doing it. So now I have 3 plus, actually instead of plus, it's going to be 3 is less than or equal to x minus 3y. Now, the reason I say it's faster is because I can use intercepts. So watch this. If I want to find the x-intercept, all I have to do is set y equal to 0, and I'm left with the answer. X is greater than or equal to 3, right there. Now I can rewrite it this way. 3 is less than or equal to x, or you could read it the other way. X is greater than or equal to 3. Notice I switched the inequality sign because I want to keep the open portion of the inequality towards the x. So I'm going to go over 3 spaces on the x-axis and put a dot. Now I can find the y-intercept, and the y-intercept is when we're going to cancel out the x term. Set that equal to 0. You're left with 3 is less than or equal to negative 3y. Well, you've got one step of dividing by that negative 3, and then we've got our answer. Now remember, when you do that, you've got a couple things to change. First of all, it becomes a negative 1. So we have negative 1 is now greater than or equal to y. So notice the inequality sign switched. I could also read it this way. Y is less than or equal to negative 1. So I go down one space and put the dot there, and now I can draw the line. Well, it's a solid line because it has the line underneath. So I'll draw that line. And now I want to figure out which way I should shade. Well, you can either use the x component or the y component to figure that out. X has to be greater than or equal to 3. Greater than means bigger values. So go somewhere on the line. It doesn't really matter where. I'm going to just start right here. And the value of this x component needs to be bigger than. So it's going to shade this way. Here, if I use this point, the value of x needs to be bigger than. That's what the inequality says. See, it's open towards the x. When I look at the y value needs to be less than negative 1 in this case from here, or less than any y component. So notice that you're going to either shade to the right of the line or down. It means the same thing. So it doesn't matter which component you look at, either one's going to tell you which way to shade. Well, let's look at the next line. Now this is the example of the vertical line. So we have a vertical line when it's just an x, there's no y. And so you start at negative 2 on the x-axis, and you draw a line. See, people wonder, well, how do you know which way it goes? Well, if it was a horizontal line, there would be so many x values you couldn't count them because all the points would go right along the x-axis. So in order for x to only be negative 2, we draw a vertical line. Now, I said only negative 2. That's if it equals. But this doesn't. This is x is greater than negative 2. So we draw the line through negative 2 to represent the boundary or the border for ones that are solutions and ones that are not. And in this case, x is greater, so that means we go towards the bigger x values, often towards the right, towards the bigger numbers. It's off towards the right. So the only area that ends up working, that has solutions that work, are to the right of that blue line and below the black line. And so that's where we end up shading. Well, that's a little review on graphing systems of inequalities. The next problems, all the problems after that, deal with exponent rules that we'll be talking about on Monday, Tuesday, and Wednesday of this next week when we come back. Well, here, what we do, this first problem, number 3, is seeing if you understand negative exponents and what to do with them, and then also the exponent of 0. So what we have to remember is anytime you have any number or variable to the 0 power, this equals 1. So that kind of cancels that term out. 1 times a number doesn't change anything. The next rule is when we have negative exponents. Negative exponents, we want to take their reciprocal. So we kind of just switch their location in the fraction. Do the same thing with this. Negative to the negative second power. You switch its location in the fraction, and then it becomes positive. So that's all I'm testing you on there. Do you understand the rule of the exponent of 0 equaling 1? And do you understand that when you have negative exponents, take their reciprocal, basically switch their location in the fraction, they become positive. The negative number here, negative 4, didn't do anything there except to try to fool you. So negative 4 stays where it's at. 1, r to the 0 power is just 1, so we don't have to worry about that. Q to the negative second, that went down below. But the t to the negative fourth, that goes on top, and it becomes positive. So we have positive exponents on top. Q to the negative second, that goes down below, and then the exponents are positive. And so that's our answer. So on your test, just show me. Just circle the parts that are negative and move them to the correct spot in the fraction. Anytime you've got r to the 0 or anything to the 0, it's just 1. So that's what I'm testing on that, on number 3. Now number 4, I'm testing you on to see if you understand the concept of multiplying values or terms with exponents, and then we have a common base. And the rule is basically this. You take those exponents that have the same base, in this case the x, and you just take all of the exponents, the 4, the 8, and this exponent, which is 1 if you don't see the exponent's 1, and you add up those exponents. That's the rule when you're multiplying. Add up the exponents. Then you do the same thing with these terms here. So the other base is y. So we're going to take the y values, and we'll write that one down. Y to the negative fifth, and times by 2, so it's going to be plus 2. So we always add the exponents when we're multiplying. So let's see what's left over. When we add up these exponents, we have x to the 13th power, and we have y to the negative third. Notice I subtracted because they're opposite in sign. Well, you're not done yet. You'll get most of the credit for this, but you're not going to get all of it because of the negative exponent. See, the directions are going to ask us to simplify, and I didn't write that down, but the directions do say to simplify on the problem. You can look on your study guide and you'll see that. Well, simplifying means get rid of these negative exponents. So what you need to do is you need to write this as a fraction. So just draw a fraction bar here. You can put 1 underneath if you want, because that's what you do. If the number were just like 4, you'd write as 4 over 1. You just take the negative exponents and you switch their location in the fraction, and then you'll have your answer. So then it would be x to the 13th over y to the 3rd. And that would be our answer. Well, the last problem is seeing if we understand that concept of adding up exponents when we have the same base, but we also have coefficients in front of all these terms. So it's a little bit different problem. Well, all you're going to do is the same sort of thing. You're going to take the common bases with the exponents and separate them, just like I did here, but the coefficients you're going to do the same thing with. You're going to take all those coefficients, -2, 5, 4, 3, bring those all together and multiply them. See, everything's being multiplied. You can use the commutative property, and that allows us to switch the terms around, and in this case, we're going to multiply them all. Now we're going to take all the x's. So again, everything's being multiplied, so times by all the x components. Now look how many x components we have, and once you get them, we've got the x to the -3rd, x to the -2nd. Write down all those exponents and add them together, -3 plus -2. Now let's take a look at the last one there. We've got a y component, y to the 3rd, y to the -4th. Write that one down, y to the 3rd, and we're going to add on that -4. And so again, you're just adding up the exponents when things are being multiplied. And take a look at what's left here. So you're going to multiply all these numbers. This makes -10, this makes 12. You see, you multiply those numbers, and we get -120. Now you count up the x's. Well, there's -3 and -2 make -5. Do the same thing here. You got 3 plus -4 makes -1. So I had to subtract because they're opposite in sign. Well, you're not done yet. Remember I said you have to simplify. The directions say to simplify. That means get rid of any negative exponents. Well, we got 2 of them here, right? This is a fraction. And then take those negative exponents, x to the -5th, y to the -1st, and switch their location in the fraction. And rewrite what you've got. And so it becomes -120 over x to the 5th multiplied by y to the 1st. So you can write it this way. If you didn't write that extra 1 as the exponent in front of y, that's fine too, because it's not necessary. But the -120 needs to stay where it's at. And so we don't change negative numbers, it's just negative exponents that switch locations. Well, in the next part, we'll have problems 6, 7, 8, and 9.